9 countries currently maintain a global arsenal of roughly 15,000 nuclear warheads, deployed daily in underground silos and patrolling submarines. These weapons are often depicted as doomsday buttons that defy human comprehension, existing in a realm of apocalyptic myth rather than science. In reality, they are physical machines operating according to predictable laws of physics and cause and effect. Their power is drawn from the atomic nucleus, where energy is released through controlled nuclear reactions and radioactive decay. Every stage of a nuclear explosion follows a sequence of highly engineered physical processes. Inside the metal shell of a standard atomic bomb, the goal is to trigger a fast, self-sustaining chain reaction by splitting heavy atomic nuclei. This process requires specific fuel, either uranium-235 enriched to at least 80%, or the artificial isotope plutonium-239. To start the reaction, you must concentrate enough fissile material in one place to reach what physicists call critical mass. A truly destructive weapon requires 4 to 5 critical masses. However, packing that much raw material together in a stable state would cause it to react prematurely. The implosion method solves this. An outer ring of conventional explosives is detonated to create a guided shockwave that moves strictly inward. This inward pressure violently compresses the central core, rapidly increasing the density of the uranium or plutonium. This compression achieves the required density of 4 to 5 critical masses in an instantaneous surge of energy. An atomic explosion is a mechanical process. It uses a conventional explosion to crush atoms together until they are forced to split. Hydrogen bombs scale this destruction even further. Instead of only splitting heavy atoms, they use thermonuclear fusion to fuse light elements together. While early atomic bombs yielded between 13 and 21 kilotons of TNT, the thermonuclear Tsar Bomba reached a yield of 58.6 megatons. To reach that scale, the bomb uses an integrated atomic device merely as a detonator for a larger fusion cylinder. When the atomic trigger fires, it releases the heat and energy required to ignite the secondary fusion reaction. Under this extreme heat, elements like deuterium and lithium hydride fuse together, creating a secondary blast that vastly eclipses the initial detonation. A hydrogen bomb's power has no theoretical limit because it uses a complete atomic detonation as the match for a much larger thermonuclear fire. When the reaction breaks the casing, it results in the violent expansion of a physical shockwave and intense light radiation. Following the blast is the lingering threat of ionizing radiation, which manifests in 3 distinct forms. Alpha radiation is easily blocked by clothing, but beta radiation can cause burns and cataracts from tens of meters away. Gamma radiation possesses extreme penetrating power, requiring thick lead or concrete to block. It permeates the body directly, causing radiation sickness, cancer, and genetic mutations. The shockwave destroys the infrastructure, but the ionizing radiation creates the sustained biological legacy of the blast. On a global scale, we can calculate what would happen if all 15,000 warheads were combined into a single weapon. This chart shows the total yield of the global arsenal. At an average of 500 kilotons per warhead, the total force equals 7,500 megatons. We can compare this 7,500 megaton total to the Chicxulub asteroid impact that ended the era of the dinosaurs. The entire combined power of the human nuclear arsenal is roughly 13,000 times weaker than that single asteroid impact. While this force is insufficient to physically shatter the planet, it remains an efficient tool for the erasure of human civilization. The physics and mathematics of the global arsenal define a specific, measurable limit to its power. These weapons operate not as mythical artifacts, but as machines with specific, physical consequences.